This is our sample problems for the KSP problem. So we're going to start with type 1. And your sample problem in your notes says, what will the concentration of I- in a saturated solution of AgI where Ag plus is 0.01? So the first thing you do is you write the KSP expression. And it is always the two ions that make up your solid. Well, in this case, it's Ag plus and I minus, because we're trying to find the KSP of AgI. So they've given us the KSP, which is 1.5 times 10 to the negative 16, really small number. They've given us Ag plus, which is 0.01 molar, and they want us to find I minus. So it's simply a dividing question now. So I minus is going to equal 1.5 times 10 to the negative 14 molar. Now don't forget to put your units in because this is talking about concentration. Now for type 2, we're given the solubility of BaSO4 is 3.9 times 10 to the negative 5 moles per liter, and we have to find the KSP. So BaSO4, if I disassociate it, it is Ba2 plus and SO4 2 minus. So it's all a 1-to-1 ratio. So if this is 3.9 times 10 to the negative 5, so will this, and so will this, because it's all a 1-to-1 ratio, because we have those unwritten ones in front. So KSP expression is your Ba2 plus and your SO4 2 minus. We stick the numbers in. We have 3.9 times 10 to the negative 5 times 3.9 times 10 to the negative 5. And we get an answer of 1.52 times 10 to the negative 9. Now remember, KSP, just like KQ, KA, etc., does not have units. So now we're going to move on to example number 2. So the first thing I'm going to do is disassociate the chemical in the question. So I have Al3 plus, add 3 OH minus. We have to be a little careful on this example because we don't have a 1-to-1 ratio for each one. So we know the concentration for this is 0.004 molar. And this will be 0.004 molar as well because there's a 1-to-1 ratio. But this one we're going to have to times by 3 because of the 3 in front. And we get that equal to 0.012. So we are going to be using these two concentrations in our problem. So again, we write the KSP expression, which is always our ions, Al3 plus times OH minus. Now remember, because we have a 3 in front, that becomes an exponent in our KSP expression. So you stick the numbers in, do the math, and you should get 6.91 times 10 to the negative 9. Now remember, when you're doing these problems, you should be trying them on your own to make sure you get that answer in your calculator. Now with our type 3 problem, it's a little bit different because we are given the solubility in grams per liter instead of moles per liter. So after you write out the chemical and you disassociate it, like you see I've already done, we have to calculate the 0.18 grams per 1 liter into moles per liter. So you do that by using the molar mass of CaF2, which happens to be 78.1 grams. You do the math and you get 2.3 times 10 to the negative 4. So that means this is 2.3 times 10 to the negative 4. This is 2.3 times 10 to the negative 4. Believe me, that's supposed to be a 4. But with the F, we have to multiply it by 2, so it's going to be 4.6 times 10 to the negative 4. And we times it by 2 because of the 2 coefficient in front of it. So now we carry on as normal. Write your KSP expression times F minus squared because that coefficient becomes an exponent. You put your numbers in for concentration. Don't forget to square it. That's a common mistake students make. And you should get 4.9 times 10 to the negative 11. Of course, types 1 to 3 are fairly simple, and now we're going to move into type 4, which is a little bit more complicated because we have to use the variable x because we don't know any concentrations. So it tells us that Ag2S has a KSP of 1.6 times 10 to the negative 49, and we need to find the solubility or concentration. So solubility and concentration mean the same thing. So the first thing I'm going to do is disassociate. And I don't know what this is, so I'm going to call it X. I don't know what this is, I'm going to call it X because they have a 1-to-1 ratio. And this one's going to get called 2X because of the 2 in front. So my KSP looks like this. Ag plus, concentration of it squared, times S2 minus. And I know the KSP is 1.6 times 10 to the negative 49. That came from the question. This is going to be 2x squared, and this is just going to be x. So I have 1.6 times 10 to the negative 49 equals 4x squared times x. So 1.6 times 10 to the negative 49 equals 4x to the cube. So we divide both sides by 4, and we're going to figure out that x cubed equals 4 times 10 to the negative 50. So this is where you have to use your cube root button on your calculator, so it would look like that. And you find out that x equals 3.4 times 10 to the negative 17. Now it said to find the concentration for the Ag2S, so this is your concentration, so we put an M behind it. And that's part A answered. Part B wants that number in grams per liter, so we're going to write out 3.4 times 10 to the negative 17 moles over 1 liter, which is the same as capital M. And this time we're going to times it by the molar mass, which is 247.9 grams over 1 mole. And you'll notice our moles will cancel out, and we get a final answer of 8.43 times 10 to the negative 15 grams per liter. And again, try that in your calculator to be sure you get the right answer. Type 5 is our most complicated type of KSP problem, and it's asking you to find if precipitation will occur or the QSP, which is also known as the ion product. So what that means is we'll be given the KSP, which is a value from a table, and we're going to find out if the QSP equals that. And QSP just means the same as KSP, except it's an experimental value from the numbers given in a question. So first thing I'm going to do is disassociate AgCl, which is what our solid is going to be, because that's what the KSP was. Let's make that look a little better. And so KSP equals Ag plus times Cl minus. Now to get the concentration of Ag plus and Cl minus, we have to use the information given in the question with our other two compounds or solutions. So I'm going to start with the Ag2SO4, and we'll come back to this KSP in a bit. So I'm going to disassociate this. And I know I have 250 milliliters of 0.01. So I have to use C equals N over V to find the number of moles. So I have 0.01 as my C. My volume is 0.25 liters. I cross multiply, and my N equals 0.0025 moles. So that means this is 0.0025 moles. This is going to be doubled, so it'll be 0.005 moles. And this will be 0.0025 moles. Now we will end up using this value to help us find the concentration of Ag+. Now before we can do that, we need to do the same thing with the FeCl-. So Cl3, gets disassociated to Fe3+ and 3Cl-. So again, we're going to use C equals N over V. This time it's a 0.02 molar concentration, We're trying to find N, and V comes from 0.25 liters because we had 250 milliliters. So we do the cross multiplying, and N is going to equal 0.005 moles, sorry. So this will be 0.005 moles. This will be 0.005 mole. And this will be 0.015 mole because we had to times it by this 3. So now we can try to find the concentration of Ag plus and Cl minus, which we need for our original KSP. So again, we're using C equals N over V. Our number of moles is the number we calculated earlier to be 0.005 moles. Our volume now is a sum of the 2 volumes in the question. So instead of 250 milliliters, it's 500 milliliters, so 0.5 liters. And we get an answer of 0.01 molar. We do the same thing with Cl. This time our moles are 0.015. Volume is the same, so it's 0.5. And we get 0.03 molar. We take this information and we put it into the KSP expression that we wrote earlier. So we just figured out Ag is 0.01 molar, Cl is 0.03 molar, and when you do the math, sorry, we call this QSP, not KSP. And when you do the math, you'll find that the answer is 3 times 10 to the negative 4. Now this is much larger than the number we were given for KSP in the question. So because QSP is larger than KSP, that means when we mix these two solutions together, a precipitate or a solid will form. And that solid will form until we have QSP equaling KSP in the actual reaction. So this is the hardest problem we have. And when you get to the worksheet, this will be what you're doing on questions 14 through to 17. So if you need help, be sure you contact me. Good luck.